Hey, Tutorinos, this is Tutor Pat coming at you with an in-depth discussion of the first functional family, the linear family. So let's quickly recap what a function is. A function is just a mathematical relationship where for every single input, there is but one output. And because of this unique one-to-one relationship, functions can be portrayed in one of three ways, either as equations, or as graphs, or as tables. And each of these portrayals or understandings is co-equal with the other. So to best illustrate this, we need to talk about the families of functions. Functions are differentiated by the degree of x in the polynomial. So when x is to the first degree, it is linear. When it's the second, it's quadratic. When it's the third, it's cubic. And when it's to a variable degree, meaning anything from 4 to infinity, we call that an exponential function. Well, today we're going to focus on the linear family, particularly its portrayal as an equation, as a graph, and as a table. Let's get to it. So again, whenever I have a mathematical expression and I'll do something really simple like 2x plus 3, and the power of x, the degree of x, is 1. And usually in mathematical notation, when it is to the first power, it is not noted. It's just understood, right? So when you just see x all alone by itself, we can be assured that that's x to the first power. That is going to be a linear function. Now, that linear function, like all the functions that we're going to talk about, can be understood in a few ways. It can be understood as an equation. It can be understood as a graph. And it could be understood as a table. Now, as an equation, the standard form of the linear function is ax plus by equals c. Okay, so we call that the standard form. And many times, particularly on the SAT, when you encounter a linear function, it's usually in the standard form. Now, though that is the standard form, it's not my favorite form. My favorite form of the linear function is y equals mx plus b. That is called the slope-intercept form. Why is it my favorite? Well, it's my favorite because I can quickly glean a lot of key information just by looking at the function when it's in that format. Because C, late night, M is the slope. What is slope? Well, slope is rise over run. It's the rate of change of the line. Its equation is y2 minus y1 over x2 minus x1, or the change delta y over the change delta x, the change in y over the change in x, the change in the vertical motion over the change in the horizontal motion. Now, when it's in the slope-intercept format, I immediately know that the coefficient of x is going to be the slope. I also know, just by quickly glancing, that b here, that's going to be my y-intercept. It's going to be where the function, which is in the form of a line, where the function intercepts the y or vertical axis. So just as a tip, whenever I see a linear function and it's in standard form, the first thing I do is I get it into y equals mx plus b format, which is my favorite because I'm able to divine, pull out, understand a lot more information very quickly with that format. So that's understanding it as an equation. I want to talk about what it looks like as a graph. So as I said earlier, and is obvious in the name, a linear equation graphs as a line. So here's a line that's going to be a linear equation. I know it's a function because it passes the vertical line test, meaning I can throw down a vertical line, and it will only, that's not vertical, it'll only hit the graph once. So I know it's a function, meaning for every x value, there's just one y value. There's never two y values. For every x value, for every input, there's just one output. So I know that's a line. I know it's a function, so it must be a linear function. And now and I know I'll get it in my y equals mx plus b. So just to define these graphically, that b is going to be right here. That's my y-intercept. That's where the line intercepts the y-axis, my vertical axis. And how do I portray my m, my slope? Well, my slope is the change in y, my vertical change, and this is a negative vertical change. I'm going down over my horizontal change. So it would look something like this. That's my slope. And notice in the line, the slope is constant. The slope here between these 2 points, here and here, is the same as the slope here and here. That's one of the defining characteristics of a line, is that the slope is constant. Lines extend infinitely, and at any 2 points, the slope is always going to be the same. So, as a recap, b is my y-intercept, and m is my slope, my change in y. Delta is just the Greek letter that means change, over the change in x, or y2 minus y1 over x2 minus x1. So the final way that I can understand or portray a linear function is as a table. Now, we call these t-tables. The reason why we call them t-tables, it's not terribly sophisticated. It looks like a giant T. And our x's are here and our y's are there. So I can populate that with data from my points, right? I can say, all right, well, that's going to be x equals -2, y would be 1, 2, 3, 4, 5, and that would be, x would be 0, and y looks like 1, 2, 3, like 3.75, and then so on, and this would be 1, and then we go 1, 2, 3, so that'd be x equals 1, 3. And I could use this data in my table with my slope equation, my y2 minus y1 over x2 minus x1, so that if I'm going to use, and it doesn't matter, but if I wanted to use this one and this one as my 2 points, that would be 3 minus 3.75 over 1 minus 0. So my slope in this case would be -0.75, or -3/4. And indeed, we can just kind of see this is kind of going down 3 and over 4-ish. I mean, I'm just running this on the fly. So we see our linear equation portrayed 3 different ways. Our linear function as an equation, as a graph, and as a table. And the key skills we need to know are the ability to move using algebra from the standard form to the slope-intercept form, to memorize our slope equation, y2 minus y1 over x2 minus x1, to be able to look at a graph and derive the equation, or build a table, as I did here, and use the table values to determine the slope. All of these I would call the suite of essential skills that you need to develop in becoming masters of the linear function.